Every year, farmers make one decision that determines the entire season: when to sow, how much to irrigate, what to plant, and they make it blind. They won't know if it was the right call until harvest, months later when it's too late to change anything. What if you could see the outcome of the decision before you made it? This is what if farming, a digital twin of your field that turns real climate science in real time, so you can test a decision before you commit to it. It starts by building a digital twin of your actual field. Step 1. Location. I'll search for my field. Let's say Patna, Bihar. The system decodes this to exact coordinates: latitude 25.59, latitude 85.13, because everything downstream depends on knowing precisely where this field sites. Step 2. Crop selection. Each crop here isn't just a name. It's preloaded with real FAO 56 agronomic data: how long the growing cycle is, its water demand curve, and its yield sensitivity to water stress. I'll choose wheat, a 130-day cycle. Step 3 is where this stops being a generic app and starts being a real simulation. The system queries ISRIC Solid Grids, a global soil database, for this exact location and returns the real soil composition: 35% sand, 35% clay, and 35% silt, classified as clay loam using the standard USDA soil triangle. From that, it derives field capacity and wilting point, the two numbers that define how much water the soil can actually hold and release to the crop. Last step, I set my intended sowing date, November 15th, and my field size. And that's it. My digital twin is ready. The simulation is one half of the picture. The other half is satellite verification. This tab pulls real Sentinel-2 satellite data for the field: NDVI, a measure of plant vigor, canopy chlorophyll, and moisture index, all at 10-meter resolution. This scrubber moves through actual satellite overpass dates across the season, from sowing to peak canopy to harvest, so you can watch the crop's real health trajectory, not simulated, observed from the space. Done. This is the simulator, the core of the product. Before I change anything, here's my baseline. For this field, this crop, this soil, sown on this date. The system projects the harvest of 5.5 tons per hectare, using 471.7 millimeters of water, total with 0 days of water stress. These aren't guesses. Underneath, the system is running a day-by-day water balance for the entire 130-day growing season, tracking how much water the soil holds, how much the crop drinks each day based on its growth stage, and what happens when supply doesn't meet demand. You can see the crop's actual growth stages: 20 days initial, 30 days vegetative, 50 days flowering, 30 days maturation, each with a different water appetite. And this chart is the season day by day: soil moisture rising with rain and irrigation, falling as the crop consumes it, bounded by field capacity at the top and wilting point at the bottom. Right now, my crop never comes close to that danger line. Now, here's the actual point of this tool. What if this year's monsoon is 30% below normal? Watch. The system reruns the entire simulation instantly. And look what happens to the moisture chart. The curve now dips down towards the wilting point in the late season. That's real water stress, computed from real physics, not a canned warning message. But because I've sent irrigation to drip, the most efficient method, the system compensates. If I had left this rain fed instead, yield would collapse. This is the decision a farmer actually needs to see. Not irrigate more, but exactly how much irrigation method matters when rainfall lets them down. And if sliders aren't your style, you can just ask, what if rainfall is 30% below normal with drip irrigation? Same engine, plain English in, same real simulation out. And because one season means nothing in isolation, this tab benchmarks the current season against last year. Rainfall, heat stress days, growing degree days, and NDVI vigor side by side. This year's season is tracking 12 fewer heat stress days and higher cumulative rainfall than last year. Context that turns a single number into an actual decision support signal. Isn't a chatbot reciting generic farming tips, and it isn't a static dashboard showing yesterday's weather. It's a real physics-based simulation, grounded with FAO 56 water balance science, ISRIC soil data, and a Sentinel-2 satellite verification. That lets a farmer see the consequence of a decision before the season makes it for them. What if farming? See your harvest before you plant it. Once you've tested a few what ifs, you save them. And this is where you actually decide. Here are 4 safe scenarios, overlaid on one chart. My baseline, a 14-day delayed sowing, a fully rain-fed test, and a 25% irrigation deficit strategy. And the table makes the stakes unmistakable. Baseline, 5.5 tons per hectare, 0 stress days. Rain-fed, no irrigation at all. Yield collapses to 1.39 tons, a 74.7 loss. With 91 days of water stress, same field, same crop, same season. The only difference is one decision. That's the trade-off a farmer usually only discovers after the harvest is already lost. For farmers who'd rather have a conversation than operate a dashboard, there's an advisor. I'll ask, what happens if I delay sowing by 10 days to avoid early heat? It runs the same simulation behind the scenes and responds with the real numbers. 5.5 tons per hectare, 0 stress days, evapotranspiration demand of 500 millimeters, plus a chart, plus suggested follow-up questions. This is the same engine, just reached by asking instead of dragging. This isn't a chat bot reciting generic farming tips. And it is, yeah, bro. Because one season means nothing in isolation, this tab benchmarks the current season against last year. Rainfall, heat stress days, growing degree days, and NDVI vigor side by side. This year's season is tracking 12 fewer heat stress days